Over the last few years, players have logged over 100 billion hours of gameplay across thousands of titles in the PlayStation ecosystem. But back in 1991, this empire almost didn't exist. Sony and Nintendo were co-developing a CD-ROM add-on for the Super Nintendo called the PlayStation. Then, Nintendo publicly broke the partnership, abandoning Sony for rival electronics maker Philips. That public rejection infuriated a visionary engineer named Ken Kutaragi. He convinced Sony's board to pivot the Discarnic project into a standalone, revenge-driven console. To compete against entrenched giants like Nintendo and Sega, Sony targeted the biggest technological roadblock holding the entire industry back. In the early 90s, that roadblock was physical storage. Games ran on cartridges, which were expensive to manufacture, slow to produce, and offered only a tiny amount of memory space. Sony's solution in 1994 was the CD-ROM. A single disc offered 650 megabytes of storage for pennies on the dollar, giving developers a massive canvas for complex, three-dimensional worlds. To render those worlds, the PlayStation used a custom geometry transformation engine. It acted as a dedicated coprocessor, handling heavy 3D math and lighting, so the main CPU could focus strictly on running the game. Because CDs were incredibly cheap and fast to press, publishers flocked to the system. That growing library of software drew in millions of players, which in turn attracted even more developers. By offering high-capacity, low-risk media, Sony effectively eradicated the cartridge format for home consoles. By the year 2000, 3D graphics were standard. The new bottleneck was simulation, making environments react realistically and giving characters convincing physical behaviors. Sony answered with the PlayStation 2 and its bespoke Emotion Engine processor. The hardware was designed specifically to crunch complex physics, sparking massive cultural demand and making it the highest-selling console in history. That success bred immense confidence. For the PlayStation 3, Sony pushed custom silicon to the extreme with the Cell Broadband Engine. This architecture relied on one central processor, coordinating high-speed data across 7 secondary units. Powerful on paper, but a nightmare to code for. Developers struggled to parallelize workloads, creating severe processing traffic jams that crippled early game performance. This intense focus on complex, proprietary systems extended to their network. In 2011, a massive security breach forced a 24-day outage, exposing 77 million accounts. The PlayStation 3 era proved that raw computational horsepower is an active liability if the architecture is too hostile for developers to actually use. To survive the next console generation, Sony executed a total strategic reversal. The 2013 PlayStation 4 abandoned exotic silicon entirely, opting instead for a highly standardized, developer-friendly AMD x86 processor. They paired this with a unified pool of 8 GB of high-speed memory. This simple, elegant structure completely bypassed the complex data bottlenecks of the previous console. With friction removed, creators instantly maximized the hardware. They adopted physically based rendering, accurately simulating how light bounces off materials to push graphics toward true photorealism. PlayStation regained its market dominance by realizing that making life easy for software developers generated far better results than building convoluted supercomputers. Approaching the 2020s, developers hit a physical speed limit. Traditional hard drives couldn't read data fast enough, forcing game designers to hide loading times behind long elevator rides or twisting corridor levels. Sony engineered the PlayStation 5 to obliterate this seek time barrier, building a custom solid-state drive and input-output complex capable of 5.5 gigabytes per second. Game engines can now pull high-resolution assets into memory instantaneously, enabling sprawling, unbroken digital worlds without a single loading screen. Sony reinforced this immersion with the DualSense controller, using precise haptic feedback and adaptive triggers to create physical sensations that tie the player's hands directly to the on-screen action. Solving the I/O bottleneck allowed Sony to perfect the physical box, setting the stage for their evolution beyond a single device. The PlayStation 5 now functions as the premium, high-fidelity gateway into a sprawling, multi-layered digital ecosystem. Sony transitioned to a modern Metropolis model. The console is the central anchor, driving revenue through subscriptions and remote play devices. Meanwhile, pushing prestigious titles onto PC and mobile acts as marketing funnels, drawing players deeper into the PlayStation brand. Over 3 decades, they bypassed physical storage limits, standardized processing architectures, and finally mastered pure data throughput. Global hegemony was the result of systematically identifying and destroying the technological friction of every era, transforming a single revenge project into